Hello, let us look at number 2, second question from year 2009, Form B. Alright, so I'm gonna give you a little bit of time for you to read the question, and I'm going to highlight a few things here. So storm washed away sand from a beach, and as you can see, as you're going along, f of t, that's first important fact, meters per hour, that tells us that f of t talks about the rate. In fact, it talks about uh, the rate at which the distance between the road and edge changing. So this one talks about the change in the distance between the road and then the beach, edge of the water. Now, and derivative of f is given in this way, and also storm lasted for five hours. That talks about the domain, and 35 meters from the road in the beginning. That means when t was equal to 0, this will be the initial condition. Now, then let us try to look at the first question first. A. What was the distance between the road and the edge of the water at the end of the storm? At the end of the storm basically means we are looking for when t was equal to 5. So, if you had to call f of t dt from 0 through 5, would have given us, let us call it capital F of t is the distance between the road and the edge of the water. Then in this case, this will be capital F of 5 minus capital F of 0. Well, we know the capital F of 0, that was, in the beginning, there was 35 meters. That means here, we'll end up getting, we have to evaluate this one, which we're going to do with the calculator. So I'm going to call it y equals square root of t. In this case, we're going to call it as x plus cosine of x and minus 3. Now our domain has to be from 0 to 5. Alright, and let's graph it first. Oh, actually we forgot to go for zoom fit. Alright, so then here we have 0 to 5, second, calc number 7. Lower limit becomes 0, upper limit becomes 5. Notice that the x-axis has to be on top somewhere here. Then we'll end up getting, this portion is negative a.505 will be equal to f of 5. F of 5 was equal to, in fact, 35. Oh, f of 5 was what we're looking for. Minus 35. So when you add 35, what we end up getting is this. F of 5 becomes 24. No, not 24, in fact, sorry. 26.495. And in this case, it will be meters. Now let us look at part B. We need to interpret the value of this one in terms of the distance. So in fact, f prime of 4 is equal to 1.007 means the change of the rate of distance between the road and the edge of water is 1.007. Now the unit becomes f of t was meters per hour, so it will be meters per hour, but because of the derivative, it will be hour squared. Alright, so that's how we can answer part B. Let's go for part C. At what time during the 5 hours of storm was the distance between the road and then the edge of the water decreasing most rapidly? That means we're looking for the minimum value. So in this picture, we are looking at the value around here. So what I'm going to do is I'm gonna go for second calc, and then we're looking for the minimum value, which is choice 3. Actually, we'll do one more time. Left bound, since this one was 0 through 5, maybe I'll just call it left bound, that's equal to 1. Right bound, why don't I call it as 4 maybe? Guess yes. That was the minimum value, as you can see. At what time? At what time will be? In this case, x value. So when t was equal to 2.840 hour. Then in this case, we get to real, and then the region will be C graph, and you can simply sketch that a little bit if you wanted to. Now, and number D. After the storm, the machine pumped sand back onto the beach. So we're looking at after the storm is already done in terms of hours, and so that the distance between the road and then the edge of the water was going at g of p. So in fact, this is how much it's being recovered, and p is the number of days. Write an equation involving the integral expressions, whose solution would give the number of days. Okay, number of days that must be pumped to restore the original distance. So we have to go back to the original. The fact that it has to go back to the original, that means the amount of sand that is taken out has to be equal to the amount of sand that will be restored. That means part D, in fact, amount of sand that has been taken away is in fact basically 0 through, in this case, 5 f of t dt. Now, but this will be all negative, so by putting that negative sign over there, this will make things into positive. This has to be equal to g of p dp, where 0 through p becomes the variable that which we are looking for. When they're equal to each other, amount that has been taken out is equal to amount that you'll be plugging in. That will be that will find the value p that will restore the distance as before. Alright, that's it. I'll see you later. Bye bye.